Hello. I wanted to spend a little more time on a compositional effect. I think what happened yesterday is we had just gotten to it, and this would have been a good time for us to kind of hash through things, and we ran out of time. So what I'm going to do is dial things back a little bit. First, we'll talk about the very concept of a compositional effect. So I'll be a little more explicit about how to think about what a compositional effect is. Then what we'll do is go to the lab. We'll talk about how we would test for a compositional effect in that context. And I'll actually give you two different methods. So I'll talk about the way that we've talked about in class, but then in that context, we'll also talk about a slightly different way that would allow you to get a hypothesis test directly out of the analysis. So that's kind of what my plan is. So sorry if the video is reasonably long. We'll kind of see how long it takes. I think it might take about 20 minutes or so. So you can kind of click forward or as you see fit. So the first thing I wanted to do is talk about a compositional effect just in general. So in thinking about a compositional effect, if I were to go to our generic example, this is the example that we've done over and over in class, is we're trying to predict math achievement. And one of the things we're interested in predicting it from is socioeconomic status. Now in that particular example, we have students that are nested within school. So if I were to draw out my different levels, we have school and we have students. Now where a compositional effect comes into play is we could start by saying, what if I was in a specific class? So now I'm only dealing with one school. And in that context, I could try to predict math achievement as a function of socioeconomic status. Now, one thing that we did mention is the way that we can get at this thing in HLM is we go ahead and we group mean center. Okay, so I'm going to go ahead and draw this out as group mean centering. But remember, at a conceptual level, this is as though I go in and I'm in a particular school, and at that point, I want to look at the relationship between socioeconomic status and math achievement. Now, because in that context, I'm only looking at students, so we're not trying to consider any kind of differences between schools, then we would call this a within effect. So this talks about the expected increase in math achievement for unit increase in socioeconomic status. Now, another way to think about the relationship between socioeconomic status and math achievement is to say, well, what if I had the averages? So now at the school level, I will have an MA dot J. So this is going to be the average math achievement for the Jth school. And I will also have an SES dot J with a bar, which is going to be the average socioeconomic status for students in that school. In contrast, whenever I was talking about the student level, I have an MA I.J and an SES I.J. So if we were at the school level, and that's all the data we have. So now in my example, there's 160 schools, there's more than 4,000 students. Now at the school level, we could take math achievement, the average math achievement for a school, and we could try to predict that. Now I'm going to switch my notation intentionally because I'm at level 2, but that's just an intercept, and this is just a slope. And now we're taking SES and I can go ahead and subtract off the grand mean. It's not as important up here at level 2. Oh, 0J. So now at level 2, we're saying if I only use averages, then I can also look at the relationship between socioeconomic status. Now notice, if socioeconomic status works the same at the student level as it does at the school level, then we expect this thing to be the same as this thing. These two should be the same because gamma 01 here is a between effect, but it's also interpreted as the expected increase in average math achievement for a unit increase in average socioeconomic status. So if the relationship between socioeconomic status and math achievement is always the same, It shouldn't matter if we're talking about a student or if we're talking about the school. So now we have these two different concepts. We can say, well, what if we only use student data? Or we can say, what if we use only school data? Now, the within and the between are two different ways that we could estimate that effect. A compositional effect is what happens whenever gamma, this gamma 0, 1, does not equal my beta. Now again, the notation I'm being sloppy with, it's the concept here that I want you to kind of take down. It's the idea that if every time a student, if we're comparing students of one change, a unit difference in socioeconomic status, we would expect them to be different by beta. And that if there is no difference, then my gamma should describe the exact same change. It shouldn't matter the area. If, on the other hand, socioeconomic status as an average is serving as a proxy for something else, then that effect may change. In this example, I like to think of socioeconomic status here for the student as what's at home. Right, like this is whether or not the parents buy fancy calculators or if they can get the needed calculators, if they can get added study guides for their students, so if their kid's struggling. Whereas whenever we start talking about average socioeconomic status, this might talk about what's at the school. And this is becoming less and less the case, but especially in this data set. Remember, this is one to where schools drew, like a lot of their budget depended on the property tax within their area. And so it's entirely possible then that if the average socioeconomic status for a school is higher, that school may also have more resources. And that's why we might be concerned that the relationship here is different than the relationship there. So that's my compositional effect. Okay, so now how are we going to go about testing this? So if we go back to our lab, and now I will bring up, oh, actually I can do it in here. In this context, I started setting this thing up. Now, what I'm going to do is repeat the things that I was saying and setting it up. So I'm just going to slide over to the side here a little bit. And so remember, we want a within and we want a between. And so in this case, we were interested in the IQ. And that's for the ith student within the jth class now. We have beta 0j, we have a beta 1j, and now we're using common sense. So it's common sense, and we're going to group mean center it. Now, drawing from what we talked about in chapter 5, the reason we group mean center it is because it makes this thing an unbiased estimate of the within effect. So it won't be biased. It won't be pulled based on any other relationship. And so that is my within effect. It describes the expected increase in students' IQ whenever we're comparing a unit increase in common sense. So it is, again, talking about students. Now the tricky thing is, how do we get at this between effect? Remember whenever I was talking about the compositional effect, the between effect all of a sudden moved up to this second level. And it just so happens, because I have group mean-centered common sense, this thing is average class IQ. So now all of a sudden I have a beta 0j. We're calling it in the context of HLM now. It's that intercept. But it is like that mean. It's the average dependent variable at level 2. And so that means to get at the between effect, I need an average common sense. So I can come along with my common sense, except now I have to compute this thing. Now, average common sense, I'll also call this the aggregate of a variable. We're basically going into every single class, computing the average common sense, and now we are plugging in that value. So I have average class common sense, average class common sense and I'm predicting average class. So what that does is that makes this thing the between effect. Now it's HLM, so we can't just stop there. We've got this beta 1J. And what happens is, just to kind of keep things clean, the way the book presents it is we only have a gamma, so there's no random effect. Gamma at this point is assuming that the within effect is the same for every single school. And so now we have a gamma 10 that describes a fixed within effect. We have a gamma 01 that describes a fixed between effect. And now we can get at that compositional effect. So the way we would get our compositional effect is I take gamma 01 and I compare it to gamma 10. Now I know this notation is going to get confusing. So remember, our gamma 01 is the between effect. And actually, if you're following along in the text, we would call it the B, beta B. This thing is my within effect. And we're going to call that beta W. So when we take beta B and subtract beta W, what we get is what's known as beta C, which is the compositional effect. Okay, so our compositional effect is the difference between the between effect and the within effect. Okay, so now we want to go to HLM. So we want to see what that compositional effect is in this case. Remember, we're trying to get a gamma 01, which is how the average or the aggregate common sense predicts my intercept. And we want to get a gamma 10, which is going to be the within effect. So if we go to HLM, and here I've already set it up, I've got IQ in here. Now we want to go ahead and put in as a group-centered variable common sense. Now it automatically has my gamma 10 set as fixed, so I'm not going to add in that random. But what we also want then is we want to include the aggregate. Now this data set already has it. The MCS stands for the mean of common sense. That's where the M comes from in my notation. And that is the average common sense for that class. So if I add this thing in, and we can grand mean center it, or we can choose to just put it in directly. But what that provides me now is a gamma 01 and a gamma 10. So now if I go in and I run this analysis, okay, now if I were to scroll down, and I'll move it over here, now we have my gamma 01. Remember, that's of the average common sense. So that's telling me whenever I look at the average relationship between common sense and IQ, the coefficient is 0.24, meaning there appears to be very little, or at least the relationship isn't as strong whenever I look at average common sense and how it predicts IQ. Ironically, it is significant in this case. On the other hand, if I look at the within effect, so now this is my gamma 10, it's a 1.22. So if I actually wanted to compute what the compositional effect was in this case, sorry, I moved my windows around. So now I have, if I'm plugging in, my gamma 01 is 0.24. I subtract off my gamma 10, which is a 1.22. And what that makes this is a 0.98 negative. So the compositional effect in this case is a negative 0.98. Now one thing you might ask is this significant? And there's two different ways we can do this. In the context of HLM, we can actually go in and have a hypothesis test. And we have not talked about this. You'll see that the homework just asks if they're different, and all you do is comment on it. But if you actually want to test for this, there's going to be two ways. The first way, in HLM, we can actually define hypothesis testing. So if I go under hypothesis testing, and I say I'm going to do a hypothesis test, I can define a contrast. So if I want to actually compute the compositional effect, I'm going to take the weight 1 times my gamma 01, and then I'm going to add it to a -1, sorry. times this thing. So the way this works is we assign weights. It will add everything together. So it's going to be 0 times this gamma 0, 0, 1 times this, and minus 1 times this, and then adds it up. As a result, this will be the compositional effect. And now if I were to run this analysis, at the very bottom, it gives me what that comparison is, and it gives me the standard error. So now it's actually providing me with a way that I can go about and actually test this compositional effect. I could take this, divide it by the standard error, and that thing would follow approximately a t-squared distribution, or it would basically follow a z distribution. So anytime that that value is greater than 1.96, we could actually look at it and tell. So we can see that that's one way that we could actually test for it. Now there is a second way, and this second way is discussed in the book, but it's not, we have not gone over it. And I wouldn't expect you to know it. So the second way that we could do this is if instead of group mean centering, we grand mean center. Now by grand mean centering, beta 0 is now everything after controlling for this relationship. So beta 0j at this point is now described as the average IQ after adjusting for common sense, which makes gamma 01 the compositional effect. It's the extra relationship between this and my adjusted. So this thing all of a sudden becomes what can't be explained by the original relationship. Now I know my explanation is not going to give you like an intuitive idea of what that is, but I will show you that if we run the analysis, what I should get now is my gamma 01 is in fact my compositional effect, and now we can test it. So again, at a conceptual level, compositional effect is whenever I have a particular variable that if I look at how that variable predicts my level 1 outcome, it does it in a very different way than if I look at the averages and how they're related to one another. Sometimes this is useful. So this is something to where if that's your specific research question, then you might be arguing that we can't use something as an indicator for a particular outcome at the same level or across levels. Where I've seen this is like accountability, to where we try to use a test to predict a student's ability, but then we make the argument that we can't use the average student score to describe something about the average teacher ability or ability at that class. So it's those types of things. I hope this helps. If you have any questions or anything like that, please let me know. See you later.